Welcome to Byte-Size Data Science. In the previous video, we looked at decision trees that can be used for classification or regression. Today we'll move to a clustering algorithm called k-means. The idea behind k-means is to partition the data into k-clusters or groups. Why grouping? What about finding out where is the best location for new hospitals in an area, or where a bank should install ATM machines, or any type of segmentation for customers, products, or even for recommendations? Let's see how k-means work. We have a set of points in a two-dimensional space. We want to group them in 4 clusters. The result is 4 cluster centers where a point is associated with the closest center to it. We start with 4 random values, in this case, 4 data points from our dataset. Note that the starting points may not lead to the best grouping, so multiple starting points should be tried when creating the model. We then associate the data points with these centers. Then we calculate the real center of each given grouping and reset the center value to the calculated value. Note that one of our center was not used since in the first step it did not have any points closest to it compared to the other centers. We repeat the process, but since the centers have moved, the association is different and our lonely center now has additional members. We continue the process until the centers stop moving in a significant way. Let's see this in an animation. It is sometimes easy to see what the grouping should be when dealing with 2 dimensions. You can imagine how difficult it could be if we are dealing with dozens of dimensions. The use of k-means raises 2 interesting issues. What if some of the dimensions are not numbers? Also, since a clustering is a matter of distance, what if some dimensions are much bigger than others? Think, for example, of age and income, where age is likely to be below 100 and income can easily be above 50,000. So, non-numerical values such as gender can be converted to numbers like 0 or 1. Other values may fit a range instead. For example, if we have a satisfaction field that contains very satisfied, satisfied, neutral, dissatisfied, and very dissatisfied, that can be converted to numbers. As for the issue of scale of the attributes, that's where normalization comes in. An attribute value can be represented as a relative value related to the entire set of values. Remember the normal distribution curve? We saw it a few times already. We know that the means is the middle point of the value range and that the standard deviation is a measure of spread. A standard deviation has a different value based on the spread of the data, so if we expressed our values as a number of standard deviations, we have a comparable scale between attributes. One commonly used normalization method is the z-score. As we see here, the z-score is the value minus the average divided by the standard deviation. The result is a value roughly between -3 and +3. The thing to remember here are first that you should always remember the need for normalization. Second, that normalization is not mysterious. In summary, k-means is a clustering algorithm that groups your data in k-clusters. This is useful for customer and product segmentation, finding the best location for service centers, and more. See you next time on Byte-Size Data Science.